Okay, Chapter 10 is focused on calculating for the principal and the interest, the rate, and the time. It's a banking type of terminology that you need to become familiar with. Let's go ahead and take a look at the handout that I provided that's available in one of the links within your learning management system. The principal is the original amount that you borrow from the bank, perhaps. The rate is the rate that the interest was charged to you for borrowing that money. And the time is the amount of time that you wish to borrow that money, and the time can be expressed in days, weeks, months, and years. And the maturity value is the value of the note, which includes the principal plus the interest. So at the end of its maturity date, the original amount that you borrowed, which is the principal, plus the interest that you paid for that period of time, will be added to your principal, and the maturity value is the complete or the total payment that you make to perhaps a financial institution. The interest is the amount in which it costs to borrow the money. Okay, so here is the simple interest formula, and it's very similar to that of the part, base, and rate. You remember with the part in the point, the base in the bottom left, and the rate in the right. That's easy to remember. You have three formulas whenever you're calculating for one of those three. Well, we do the same thing with the simple interest formula, but I couldn't come up with anything quite as clever as the part in the point, the base in the bottom, and the rate in the right. But I do with the simple interest formula. You can easily remember it by I use PERT shampoo. I is the interest, P is the principal, rate is the rate, R is the rate, and T is the time. If you're looking for the interest, cover up the interest, and those vertical lines are multiplication. So it would be the principal times the rate times the time. If you're looking for the principal, cover that up, and it's interest divided by the rate times the time. If you're looking for the rate, cover that up, and it's interest divided by the principal times the time. And if you're looking for the time, cover that up, and it's interest divided by the principal times the rate. Now, the time is the main component that really gives us a little bit of an issue. If it's for a specific period of time, like 3 years, then the time would be expressed by taking it times 3 for 3 years. Or if it were 3.5 years, it would be like half is 1 divided by 2, which is 0.5, so it'd be 3.5 years for 3.5 years. If you express it in months, then you would take whatever the component is times 6 months divided by a total of 12 months. If you decided to go, instead of saying 1.5 years, you can use it in months, and you could say times 18 divided by 12 months in a year. And if you use weeks, then you would take the number of weeks divided by the total number of weeks in a year, which is 52 weeks, so 15 divided by 52. Well, there's two different types of interest or terms that you will hear, and that would be, especially whenever you're focusing on the number of days in a year, there's exact time, exact interest, and then there's exact time, ordinary interest. Notice for the exact interest and the ordinary interest, the word exact time is in both of those particular terms. But the second part of the term changes. Exact time, exact interest is on the exact number of days in a year, which is 365 days in a year. And they don't consider the leap year 366. So exact interest is always 365. But the exact time ordinary interest is also called the banker's method, and that's based upon a 360-day year after they subtract out some of the major federal holidays. We have this particular problem right here. Let's say that we have a $10,000 principal. So I put $10,000 right there. And the rate is 12% or 0.12 whenever you move the decimal point 2 places to the left. And then the time is 6 divided by 12. 6 months. 12 months in the year. And We're going to calculate for the interest, and we're going to calculate for the maturity value. So I'm going to cover up the interest as if it doesn't exist. Okay, so I'm covering up the interest. So therefore, interest is equal to principal times the rate times the time. So 10,000 times 0.12 times 6 divided by 12 on your calculator will give you $600 for the interest. Okay, then add 600 to the principal of 10,000. Those two together, added together, will give you 10,600. That's the maturity value on this particular problem. Okay, let's go ahead and look at this for each of the specific components. Okay, we have interest of $80, and we have principal that we're looking for. We don't know what the principal is, but we have rate of 12% or 0.12, and then we have time for 60 days. Now look up here in the problem, and the time is ordinary, so that's a 360-day year. So I'm going to put that over 360. I forgot to put that on the handout. And so I'm solving for the principal. The principal is equal to the interest divided by the rate times the time, which is right there. So I'm just going to fill in the blanks. Okay, I know that the principal is 80, so I'm going to put 80 on top. And since it's by itself, I'm just going to go ahead and bring it across and put 80 on top over here. But I want to calculate this next part. I'm going to enter on my calculator 0.12 times 60 divided by 360. That's the rate times the time, and that will equal 0.02. Clear the calculator. Now I'm going to enter 80 divided by 0.02, and that will give me $4,000. Therefore, if I know that I paid $80 interest at 12% interest for 60 days based upon ordinary interest or based upon ordinary interest or banker's method, then I'm going to put that over 360. With those particular pieces of the puzzle, I know that I invested $4,000, or I contributed $4,000 or paid, either way. Okay, now if we're calculating the same problem based upon rate, let's take a look at that one. We know that our principal, we invested $4,000, and we're going to earn interest of $80, or the bank earns interest of $80, and it's based upon time of 60 days over 360 days in a year for ordinary interest or banker's method. We don't know what the rate was. So the rate is equal to the interest divided by the principal times the time. There's our formula. So now I'm going to place everything into the proper category, put 80 on top, and since it's the only value on the top row, I can go ahead and bring that over. Okay, but I do need to calculate the principal times the time, which is 4,000 times 60 divided by 360. Once I calculate that, bring that over, that's 666.66. Now clear your calculator, and now I'm going to enter 80 divided by 666 minus 0.66, and that will give me 0.12 or 12%. Therefore, the amount of that the bank charged me for borrowing that money, or the rate, is 0.12 or 12%. Okay, let's take a look at the time. Okay, this time we know that the interest is $80 and that the amount that we're borrowing from the bank is $4,000 at 12% interest. But how much time? Let's calculate it. Time is equal to interest divided by principal times the rate. Here's our formula right here. Let's fill in each of those values into the proper location. 80 is interest. It goes on top, so I can go ahead and move that over here to the right and put it on top. I don't have to calculate it right now, but I do need to calculate the principal times the rate. So that's 4,000 times 0.12 after I move the decimal point 2 places to the left. By calculating that, that will equal 480. Clear the calculator and enter 80 divided by 480, and it will give you this repetitive value of 0.1666, and it'll keep on going all the way to the end of your calculator's display window. Don't change it. Just leave it in there and multiply that times ordinary interest in a year of 360 days, and that will give you the number of days in the year of 60 days based upon a banker's method of calculation, a 360-day year. So 60 days is your correct answer. So anytime that you end up with a decimal format of 0.1234, whatever it happens to be, multiply it times 360, and that will give you the number of days in the year. Okay, then we have another area of the chapter called the U.S. rule. This particular area is many times due to improved financial conditions. A person may want to pay off a debt in more than one payment before the maturity date. The U.S. rule and the merchant's rules are methods that allow the borrower to receive proper interest credits. For now, let's look at the U.S. rule using the banker's method of a 360-day year. The name U.S. rule came from the decision made by the U.S. Supreme Court. Remember that this rule applies to multiple partial payments to assist in paying off a loan early. Okay, we many times want to pay off a loan early, and we may want to make contributions. This is the way that it's calculated for us to do this. Okay, first of all, I'm going to calculate it as if I don't make any partial payments. Okay. Okay, here is the formula that I'm going to use. Remember, interest divided by the principal times the rate times the time. I use PERT shampoo, PRT, IPERT. That's the easy way that I can remember this particular formula. Okay, the interest, the amount of interest on this one, I've already forgotten, so I need to go back to my screen and look at that. The amount of interest is, it's a $2,000 note. And it's 12% interest for 120 days based upon ordinary interest, which is a 360-day year. So 2012 and 120. You know what? I've already made a mistake right there. Let me clear that. And let me put that back in. 2,000. It's principal of $2,000. Okay, so I'm calculating for the interest, which is equal to the principal times the rate times the time. So if I calculate 2,000 times 12% or 0.12 times the time of 120 divided by 360, that equals $80. So 80 is the answer to this particular question, $80. And so I borrowed $2,000 plus $80 is equal to $2,080. That's the maturity value of this particular note. Let's hold on to that thought, and we're going to go on and look at this particular problem, and let's make partial payments. Remember, this is as if we did not make any partial payments. So now I'm going to go back to the problem and make partial payments. Okay, same situation is I'm going to use the formula. Interest is equal to principal times the rate times the time. This first one, 2,000 times 0.12, and it says Joe paid $250 after 40 days. So I want to try to find the amount of interest based upon 40 days in a 360-day years. So therefore, 2,000 times 0.12 times 40 divided by 360 means I paid interest of $26.67. I'm going to subtract that from the amount of my partial payment of $250. So that means I can credit this account for $223.33. So I'm going to subtract that from the amount of my original principal, the amount that I originally borrowed from the bank, and that leaves my adjusted balance of $1,776.67. Let's continue that process and start with that new adjusted balance. I'm going to make an additional $200 payment after 60 days. Now remember, this first one was after 40 days. This one is after 60 days. That's 20 more days later into the process. So I'm going to take my adjusted balance of $1,776.67 times 12% times the 60th day, which is 20 days later. I want to find out the amount of interest on that 20 additional days, and over 360, and that will give me interest of $11.84. Subtract that balance from my payment of $200, so I can credit my account for $188.16. Subtract that from my previous adjusted balance of $1,776.67, and my new adjusted balance is $1,588.51. Now I've got 60 days left in the note. Yes, Joe paid $250 after the 40th day, and then he paid $200 after the 60th day. So that's a total of 60 days, and there's 120 days total right there. So I have 60 more days that I need to find interest on, but I'm not going to make another partial payment. So it's my previous balance of $1,588.51 times 12%, or 0.12, times the 60 remaining days in the 120 days over 360 to give us $31.77 of interest for that 60 days. So right down here at the very bottom in this area, by making partial payments, the total interest that Joe paid was, first of all, $26.67 right there. $11.84 right here, and $31.77 right there. So I paid interest for those partial payments of $26.67, $11.84, and $31.77. That's a total of $70.28 in interest. If he waited to pay it back at the end, did not make any partial payments like I calculated for you at the very beginning, the interest payment would have been $80. Remember, I calculated that right here. Came out to $80. That's the interest payment I would have made had I not made those partial payments. Okay, now the difference between $80 and $70.28 is $9.72. That's what I saved on that particular problem, which is not a lot. So it was like, why do it in the first place? Once we get into the cost of home ownership in Chapter 15, you're going to see significant savings by making partial payments on loans that you pay off early. Significant savings. Here, partial payment didn't really make any difference other than $9.72. We will make bigger differences, and so I always encourage anyone who is borrowing money from someone to definitely try to pay it off early, and do not ever make the minimum payment. Always make an above minimum payment to try to pay off the item that you purchased early. The key component here for financial success is to, if you continue to pay the minimum payment on any of your accounts, it would take you such a long time to ultimately pay off that particular account. Always maximize the amount of your contribution to pay it off as early and quickly as possible, and that could save you potentially, depending on what the interest rate is and how much you borrowed and how much time it's based upon, that could potentially save you tens of thousands of dollars depending on what it is. Well, this concludes this particular chapter that's based upon simple interest. As we move into the next chapter, we're going to take a look at discounting a note.